welcome back as we continue our investigation into Daisy the cow. Okay, right now we're going to look at the A parameter and we're going to use Desmos. So we're going to use first up the method to put two graphs and directly comment and give it a bit of a summary. So for my next graph, back to Desmos, I might change a fraction just to sort of think about, show some changes. Now, time for some interesting parts. First up, I'm in here and I want to change this to a dotted line. So I've got my little cog. Okay, now the cog will let us choose the color. Perhaps I like green, I'm going to go with red still. And we can see the effects I've had on the graph. Okay, again, you can see, oh, that's a bit crazy, but we can see, looking at the zoom, would be good if I could bring it in enough to get a 1, and I did. Okay, so I have resized the scale. Okay, I can see, again, I'm going to highlight the points of interest. So I don't want this point here, but I do want to show the height. In particular, that the height is now 1/3. Indeed, the height is the A number. I might bring in the word amplitude. So I've made this change. So far we've used the spanner. Now the little cog. Okay, I think this is ready to go across. Print screen is what I'm using. And Control V or paste. Okay, immediately zooming into a bit of cropping to get a good picture. Pity about that being highlighted still, but it's not a great issue. Okay, so just to make sure we're all clear on here, I've clicked on the picture, I've right clicked. I have a lot of different options, okay, but this one comes up pretty quickly. This is the cropping tool. Okay, also we might be doing wrapping, but here is the caption. Is 1/3. Okay, you see here that we might put this one in some quotes. Okay. It varies only by 1/3 above and below the principal axis. Now the principal axis, of course, is the line that goes through the middle of the graph. A really is the amplitude. It controls how much it goes up and down. Okay, so we might actually just put a little bracket here. Principal axis is y equals 0 on both graphs. 0 on both graphs. Okay. And we could go and make some other calls to clearly show that the period remains 2 pi for both graphs. What is the effect of changing A? Both graphs have the same period, indicating that A parameter does affect period of the graph. Indeed, A does not affect any of the horizontal features of the graph. So if you get to the graph there is only 1/3. Good to do a reread of your sentences, by the way. 1/3 of below parenthesis. Parameter A is linked to the amount of change the graph. Okay. So what I've tried to do is make a direct statement that talks about what I'm seeing. I'm interested in making this statement slightly different to the statement above. I'm always going to keep rereading the sentence. I'm a bit worried about this. I might come back and change that at some point. Here we have some heads up, and this of course is going to say affect, I would imagine. Yes. Alright, so now we're going to look at the more peculiar of the A terms, and that is the negative value. To Desmos. Okay. -2. Okay, I've chosen the number that's, I'm probably not going to have to change this graph around too much. So the period is unchanged. However, the normal maximum of pi/1 has been across to here. Now I'm actually going to add a little feature here where we are going to show that point. So I can come along here and I want to highlight that point. So I want to make a little comment. So pi, type in pi /2, comma 1. Alright, and this is now a live dot. You can see I'll put the coordinates in and it's allow a live dot. I can add a label, or I can add a little comment here. Maximum of red graph. Now we can tell what colour the graph is. And now I'm going to come down here and highlight this point, which of course, the other way to get pi is use the symbols or the keyboard. Pi, divide, 2. Now I've got a comma somewhere. Well, comma's on the keyboard, I think. Or your arrow key, go across, comma. And I'm having a guess this is -2 down here. So, -2. Alright, this point is live. Minimum. Okay, looking up here, I have highlighted the points of interest. I would like to see, well, I can tell that's -2 from the graph, and now I want to make sure I can see the period is unchanged again. So the period from both graphs is still 2 pi. This is ready to go across. Now I'm ready to print screen and take that across. So we'll go to find the print screen button and into the Word document. Print screen, crop picture. There you go. Okay, maybe this picture needs to get a little bit larger so you can see it. I think that would have been alright on the page. New line. In figure 3, the graph of Synex has been reflected across the x-axis. One of those times where the maths word is probably about as clear as anything we could say in other words. But I'm going to be very direct and say the old maximum has been turned into a new minimum. The old maximum height has been transformed, transformed into a minimum of -2, which is equal to A. The period of both graphs remain the same. Indeed, I might the period and principal axis, both graphs remain the same. Okay, now some sort of summary here would be talking about how the A affects the amount of change and is called the amplitude of the wave, and measures the distance from the principal axis to the top. And if A was 10, for instance, that height would be 10. Some sort of summary would also explain what wasn't changed. So to continue, we basically did a summary talking about what the changes are on the graphs on this page. In the example document, this was all summarized in a table, which is the other approach. Here's some graphs, make a table, make your comment here at the back, at the bottom. You can see that I have got some of the specific language coming up. One thing that I did miss out on at this point is, for instance, if I go across to hazy, we see the word vertical dilation and the scale factor. That's certainly fine. We could use some of that information. But I did want to point out that in this performance stances, the results in the context of the problem, or logical conclusion. So I'm clearly interested in how this A letter would apply to a model. If I was to change A to 4 or 2 or 12 or make it bigger, what would happen on a model? A is clearly most related to the height or the amount of change. So if the child changes by 5, A would be 5. So perhaps important that we could attempt to make a sentence that links the letter to the model. Okay, well, this was a pretty long video, and I will actually do parts of this video in a separate video where I just very briefly, quickly go through some of the skills involved in the graph. Thank you. Thanks for listening.